Hi everyone, my name is Sean Power. I'm an application security architect at DOSarrest Internet Security. DOSarrest has been an innovator in internet security since 2007. It was first created to help data centers withstand these large-scale denial-of-service attacks that would come in targeting one client, but the attacks would come in and they'd overwhelm the infrastructure and take down many clients. So DOSarrest was created to mitigate these threats in the cloud, which would keep the website online and avoid all that collateral damage to the data center. And as new technologies have arisen and attacks have become more sophisticated, DOSarrest has evolved beyond the simple DDoS mitigation to offer solutions to each new threat as they appear. I am proud to be part of the team that gets to help design some of these solutions and mitigation strategies. But we don't have time today to talk about everything that we've learned or discovered in the last 12 years. Today, I'd like to focus on one particular area that I feel is still relatively underprotected, the web APIs. Now, APIs are not a new topic. They're quite prevalent across the internet. In fact, it's getting harder and harder to find a service that doesn't offer an API. Not that anyone's looking for them, because APIs are a real asset to developers. But when you combine these APIs with developers who think that security is somebody else's problem, pretty quickly those APIs become a big liability. Just before we jump into it too much farther here, there is a chat link in your GoToWebinar panel there. So if you've any questions that come up or anything that you want me to delve farther into, feel free to put it in the chat there. And I'll go through all of those at the end when we have a question period. So APIs are fundamentally web requests. They're based on the HTTP protocol. As such, they have all the same risks and vulnerabilities that normal website traffic does. Cross-site scripting, SQL injection is just as devastating to your API as it is to a website. And furthermore, your API documentation that you publish really just helps the attackers identify potential vulnerabilities within your code. Similarly, denial-of-service attacks are particularly effective against APIs. They potentially disrupt not only your application, but any of your partners whose applications are waiting on responses back from you. Those functions in their application will be unavailable. And in addition to these standard website risks, APIs are designed to grant additional access or control beyond what a standard website would typically give. Most websites, they get GET requests, which is a client requesting some piece of information. That makes up the majority of the requests on a website. So, on any given site, there's also a select few resources that allow post requests where the clients can submit information to an application. That's where most of the vulnerabilities occur. Anytime that I can submit or manipulate information that I'm sending to your website, that gives me the most ability to interact with it, the most ability to make the changes that, as an attacker, I would want to make. APIs have a much more even distribution of those GET and POST requests. For every GET, there usually is a POST. There's also a put, patch, and delete method for adding, updating, or removing data from the application, which just increases the potential for mischief. Unlike websites, APIs are not pretty to look at, so we tend not to look at them. Throughout your regular duties, your staff is interacting with, observing your website pretty much constantly. If an attack was to impact your website integrity, maybe swapping images or defacing content or uploading malware, it'd get noticed pretty quickly. But your APIs, you monitor that they're up or down, and maybe even performance. Are they responding slowly or quickly? And occasionally do some unit testing when you've got a new patch or some new feature that you want to test. But you're only really doing those testing for those edge cases that you've already thought of. Along the same notes of you can only test what you already know, websites, they link from page to page to page, and it's really easy for an automated test to crawl, discover new links, discover new content, and it can map your whole website pretty quickly. APIs don't have the same crawl behavior. You have to test each individual endpoint individually. So your test plan is only as good as your development documentation. You're not going to discover a new endpoint that's been released, or a new piece of if you've got something installed in a directory that it wasn't meant to, you're not going to discover that with a vulnerability scanner the same way you would on a website. That's why it's imperative that your APIs have a security strength commensurate with the increased risk your APIs present. There's additional access, increased complexity, and the decreased visibility. Looking at all the possible permutation that web traffic could possibly be, normal organic human traffic is a pretty narrow window right in the middle. Our browsing behavior tends to be a little bit like Goldilocks. We're not too random, not too predictable. Machines, on the other hand, occupy one extreme or the other. They're very predictable or they're very random. So it's easy to identify human versus bot traffic, which is a valuable tool in website protection. But APIs don't have those human visitors. All the traffic is machine traffic, whether it's legit or not. So many of the tools in your website security toolbox simply don't give you the same results because there's no organic traffic for them to look at. So your challenge and response mechanisms like CAPTCHA won't work. Your browser plugin verification, those results will be meaningless. Similarly, any browser or OS fingerprinting. You've got some browser with an end-of-life Ubuntu distribution running libcurl, that could be your biggest client, or it could be a malicious attacker. Similarly, web application firewalls have got a long, troubled history with APIs. API use cases are typically the sort of thing that WAFs were designed to protect against. While I do strongly recommend implementing WAF protection for your API, and you can do it, it's not a task to undertake lightly. The WAF will need to be tuned or calibrated or modified specifically for your API traffic. There's not a WAF that's going to work out of the box. And this process is neither simple nor fast. That's why many API developers, they'll give up on the whole WAF experience after only 6 months of trying. So given this increased risk, decreased security toolset, APIs need to be tightly controlled. Here's where the intended audience actually works in your favor though. While humans were notorious for our unpredictability, bots using the API will conform to whatever restrictions you put in place. The HTTP headers to control, use them to control whatever option makes sense to you. The bots are going to obey those. They're not going to ignore your instructions. They're not going to guess at something or get fed up and move on to another website. They will read every header. They will conform. And if they can't, they're going to raise an internal alarm for their developer to fix. What's best? These bots, they're not going to try and suddenly do something different tomorrow. Another security must: always apply your security patches and updates. This is not unique to APIs. Unfortunately, APIs seem to lag a little behind in this. Aside from the usual apathy that can affect any system, API complexity has a tendency to prevent updates. Maybe the patch was applied but had some unforeseen interaction, so it was rolled back. Or some necessary third-party or legacy module doesn't have a patch yet. Or this new version deprecates or removes a function that you use extensively in your API. Attacks generally follow one of two approaches. There are indiscriminate attacks that target the root of a home page. It's a shotgun approach that goes across the internet just to see how much damage they can do and move on to the next application if they fail to achieve any meaningful results. These indiscriminate attacks are just part of the background of the internet. And while they're annoying, they're easily preventable with rate limiting or dynamic ACLs or many other simple, generally persistent technologies. Far more troublesome are the attacks that are specifically targeted. These attackers are motivated. They've taken the time to perform an initial reconnaissance. Maybe they've read through your API documentation. And depending on the motivation, these attacks will seek targets that cause the most disruption or yield the most valuable data. And they'll typically target computationally expensive resources to maximize those efforts. APIs blend all three of these target selectors. So if there is someone intent on causing harm, API is a great place for them to start. DOSarrest applies multiple layers of defense. First off the bat, we want to deal with those volumetric denial of service attacks. These are attacks that could cripple any moderately computational expensive program. which your API most certainly is. So we want these gone before we even start looking at application threats. The next few layers deal with that with specific network layer or application threats to the website. Once we've discarded all this traffic so far, requests reach the proxy layer. As we've discussed, API and website requests differ in method and content. The proxy accepts requests, all web requests, and then makes mitigation decisions based on whatever rules are configured, which we call features. We tend to say rules are with the previous layers. Features are far more complex and customizable. These features examine and make decisions based on everything from that method to the user agent reputation, geographic location, submission rate. All told, the proxy is probably looking at over 100 different indices of these web requests to determine the validity. And we're adding more constantly as new threats emerge. Once upon a time, corporate networks included a proxy server. It would sit at the edge of the network and filter the requests bound out for the internet. This proxy would block any outgoing requests to potentially undesirable websites, hosting things like malware or viruses or Facebook. Corporate users could not access the internet without going through the proxy, ensuring their computers remain free of viruses, Trojans, or Ice Bucket Challenge videos. With APIs, the risk is in the opposite direction. APIs don't go out looking for trouble like your users do. The malicious clients come looking to post and update trouble directly to your system. So what we need in this case is something called a reverse proxy. It sits at the edge of the network, or in the case of DOSarrest in the cloud, but it filters the incoming traffic, disallowing anything malicious. Even better, by filtering all the incoming traffic through the reverse proxy, you're not only removing the malicious APIs, but this very simple fact of using a reverse proxy, you're going to limit the threat surface to your application. Because you're not connecting directly to your application, you're connecting to a proxy first. It mitigates things like operating system or protocol vulnerabilities. It confuses any port scanning, anything like that, because they have to go to the proxy first. They don't have the direct access to your application the same way that the traditional proxy means that a user cannot connect to the internet. The reverse proxy means the internet cannot connect to directly to your application. Everything has to go through the proxy, and that limits that threat surface right down to next to nothing. Because proxies involve two systems, we've got slightly different terminology on each system. Both systems have pretty much the same stack of technology. Your application has got some endpoints, and they're hosted by a web server, or they include a web server. And this technology is listening on an origin IP. On the proxy, we've got the same thing, except everything is virtualized. So we have a virtual IP, which accepts the incoming traffic, a virtual web server, which contains general configuration options and handles web server level events, web server level of attacks. And then we have the specific virtual endpoints. These are created as need be to handle resource specific configurations or resource specific mitigations. We'll talk about more of these in a minute. These are the common names. These are aspects that all proxy software have, although the names change slightly from software version to software version. What I'm using today and what I'm using in these examples is Nginx. It's just my personal preference, but it refers to the origin as the upstream and the virtual endpoints as locations. So you're going to see location come up in the example here, and that's the virtual endpoint that we're talking about. Normally, there's a trade-off between security and usability. The more secure you make a system, the more rigid you make a system, and the less flexibility you have. But proxies have come a long way from a simple list of no-no websites. We can now do much more than simply block the bad stuff. We can also create rules for your desired traffic. And we add this layer of abstraction that functions as an API gateway. Once you make an API public, it might as well be etched in epoxy laminate sheeting. It's out there, your customers are using it, and they're really resistant to change. In fact, you can be sure when you have a new version there's going to be users that cannot migrate yet. Even when you're on version 3, they can't migrate off version 1. These versions tend to linger in production far too long. An API gateway allows you to transform requests from one version of API to another, creating a virtual endpoint. This allows you to publicly maintain as many versions as your customers need, while internally maintaining as few versions of the API as you want. These same virtual endpoints provide a flexibility that allows a distinct mitigation strategy on a per resource endpoint, if your application needs that, which gives you all the security you need and all the flexibility you want. So here's a really simple example of virtual endpoints. Imagine you've got an environment that's got 3 separate APIs running. You've got a production environment that's running on your default. You've got a staging environment that's the version 2 of your website that's waiting to be rolled out. And you've got an internal or private API, which is ACL'd off from the rest of the internet. And in this environment, for some reason, be it security, compliance, or the fickle whims of management, you need to start using the new version 2 user object. But due to the new design, new requirements, or the fickle whims of developers, this version 2 API endpoint is different from version 1. Rather than have all of your customers go out and change their application, with a proxy server running as an API gateway, it's a simple directive to rewrite any user requests from the old format to the new format, and then forward them on to the version 2. Everything else gets passed directly through to the production API. Expanding on that, let's say that this new user object also encompasses organization information that used to be a separate endpoint. So in this case, it's a second rewrite statement, and all of that organization information gets passed through to the new user object. Finally, that private API. Only if the request is accompanied by a valid SSL certificate, a client certificate, will the request be forwarded onto the private virtual endpoint. Otherwise, everything goes through to production. So we create the private virtual endpoint there. We call it internal, which means that you can't just simply request it off the internet. It has to go through this logic and be rewritten there. And then we put in an ACL, just in case there is one of those SSL certificates that's managed to make its way into the wild before it was revoked. Of course, as I said earlier, this is a very simple example. There's only 3 endpoints, only a couple of rewrites. But regardless of your use case is more or maybe less complicated, the point is you can do far more with 17 lines of proxy configuration than you can with 170 lines of application code. And you're guaranteed that the changes you make are only going to exist on the endpoints that you put them on. There's no risk of collateral damage. You're not going to impact the rest of your application. So the previous examples were trivial, like I said. I purposely made them trivial just for the ease of reading, but also could fit them on a single slide. I expect real-world examples to be far more complex. And they're prone to change, just like everything else. As soon as you have it the way you want, a new threat emerges, and you've got to go back and start making changes. Any strong security position requires a dedicated effort and resources. The system we have is the DOSarrest security service, DSS, is currently on its 5th iteration, and we're constantly making adaptations and improvements to it. So DOSarrest uses things called features. These features are much like configuration templates, which allow you to quickly apply proxy changes without actually having to write any lines of code. So looking at what we were talking about before in that first example, I'm going to come in here and create a new virtual endpoint for that version 2 API. And we're going to forward everything there to the version 2 origin group. Once we have that written, we're going to come in to our root location that we had before. And let's add in a performance feature for rewriting. There we go. And we're going to rewrite that user object to the version 2 user object. And then I click make live down here, and 30 seconds later, it's on the internet and done. one thing I wanted to mention, I'm putting this feature on the actual root location. I did not put it on the version 2. If I was to put a rewrite on version 2 back to version 2, it's going to create this loop and you're never actually going to serve any content. So a rewrite takes you from location to location, and it's a one-way street. So the same transformation rules that we were using before are features that we use to create virtual endpoints and to mitigate malicious traffic can be used to create virtual patches. This is applying a solution or bug fix at the proxy layer to intercept requests which are causing issues, and we can modify or discard those requests before they even reach the application. The solution is not for every issue. For cases where it's trivial to patch the application or non-trivial to apply it at the proxy, you will of course simply patch the application. Virtual patching is beneficial in the rest of the cases, where patching the application is time-consuming, risky, or just not feasible. As we've seen before, adding functionality to the proxy's configuration is relatively simple. It can be published quickly, even in response to an ongoing event. It doesn't have any dependency issues. It can't affect anything outside of the distinct endpoint where it's applied, and it doesn't require rebuilding any modules and risking introducing further bugs. So while you ultimately should apply all patches directly to the application, virtual patching gives you an immediate low-risk fix and affords you the time to develop and thoroughly test your application patch. So does proxy security replace application security? I know I kind of touched on this on the last slide, but previous experience has taught me I can never be too clear on this point. Nothing will ever replace application security. What we're talking about here today are ways to augment your application security. There's no silver bullet device out in the marketplace that does it all. What we're talking about is shoring up or strengthening your application security. There are some issues that are just simply better solved in the cloud. DDoS is the most obvious example. The attacker can't saturate your connection if that attack never leaves the cloud. Then there are some issues that could be solved in the cloud or on-premise, but if it's resource intensive, it just makes sense to block it early rather than have it handle every device just to have it ultimately blocked on the last hop. And then the point of this slide, there are some issues that can only be solved by the application. These typically revolve around business logic, information management, or key application behavior. If you're allowing weak passwords or have lax authorization or leave site backups in a public directory, there's not much that anyone in the cloud can realistically do. Furthermore, you are the subject matter experts on how your application was intended to be used. You know what the expected inputs are, so have your application validate all those inputs or content types. Encrypt everything. SSL requests are never a bad idea, even for internal traffic, unless you're using a vulnerable version like SSL. Always use the newest TLS version. And only allow the methods you need. If you don't need your clients to delete from an endpoint, simply disallow that method. Use proven authorization techniques. Your customer base is a valuable asset and it should be treated as such. These authorization technologies are getting easier and easier to implement. And every case I've ever encountered where someone said, oh, well, we can't implement standard authorization technology X because we use technology Y. Technology Y has turned out to be a problem preventing many solutions. So if you can't use Java Web Tokens because you wrote your API in COBOL, maybe you should consider putting a pin in this whole API thing and just have your clients mail you their punch cards. So write your application using secure coding practices. Make sure you cover the fundamentals. And I strongly recommend you consider protecting your shiny new API behind a reverse proxy like DOSarrest. Let's see if we've got any questions here. Not so far. There is a chat link at the bottom of the GoToWeb application. So if there's anything you want to know anything more about, please feel free to send something in the chat window there. Can I tell you if your API is vulnerable? Okay, that's an interesting question, Sam. Yes, you can do web vulnerability testing to see if your API is vulnerable. Generally, most of them are vulnerable to something. I think that every API I looked at is failed about 10 to 20% of the tests, and those are the ones with a strong security position. And those are anything from specific application to, like I mentioned before, the OS vulnerabilities or protocol vulnerabilities. There's always something that could be done more. So that's where the API security comes in. It allows you to put those patches in quickly. It protects you against everything OS or protocol wise. Just simply having the proxy there limits that threat. If you want to know if your API is vulnerable, yeah, you should be testing this. It should be part of your vulnerability testing, and penetration testing should be done every time you release a new version. And that'll tell you right away if your API is vulnerable. If you haven't done the testing, yeah, I'm pretty sure your API is vulnerable. Okay, so assuming you do your website vulnerability testing, your pen testing, like I mentioned before, is that going to uncover API issues? That's what we were talking before about how APIs don't link from page to page. So when you're doing your website vulnerability, it's going to crawl your whole website. If your website sends requests through an API token, that one API token will be tested. But you're going to want to do specific testing on your API directly, because there's going to be a lot of API endpoints that you don't expose on your website. So website vulnerability testing might uncover some API issues, but you want to do specific API testing. All right, well, I want to thank everyone for coming out, listening to me talk today. If you have any more questions, or if you think of anything else that you want to get more information on, DOSarrest customers, you can email us at support@dosarrest.com directly, and they'll get an answer back to you right away. You can also email in if you're not a customer. They'll probably try and collect customer information from you, but you can just let them know that you listened to this on the webinar. They'll either be able to answer your call directly, or they'll forward it through to me. And you can always contact sales as well. They have a wealth of information and experience on what it takes to get your website protected. So again, I want to thank everyone for coming out. And hopefully we'll hear from you soon.